Alright, hello and welcome to, I guess this is week 3, right? And this is actually perfect timing because we're going to talk about this thing called the Big Three. Or 3 separate things, I guess. And this meme has absolutely nothing to do with it, but I thought it was funny. So let us get started. And here are my goals for you. We're going to take a deep dive into what C++ is doing under the hood when it's moving things around. And there are some implicit things, some features of classes that we're going to explore in detail. That is our goal for today, so that we know exactly what C++ is doing when we make an object. On the stack, on the heap, it does not matter. We want to know how the memory is moving and getting allocated, deallocated, things like that. So there's this thing called the Big Three, which up until now we have been blissfully unaware of, and today I will pull the curtain up and we will discover what's going on. So this is historically, I think, a difficult concept to learn, so maybe pay a little bit extra attention to this part. And yeah, I guess there's nothing left to do but get started. So the first thing we'll do is make a box class, and you know what? I'm just going to call it box.cpp so that we can just change it in place. Alright, so let's make a simple box class that holds one thing. So cute. I tried very hard on that. So I'm in my CSCI 41 folder. We're going to make a folder for today, lecture 5. And let's go on inside of it. And let's see here. I'm going to, well, make a file, definitely, called box.cpp. And the first thing that I want to do, I guess, is make this box class. And it'll hold one thing, so it'll have one private member variable. Let's just say it holds an int. So class box private int val, let's say. How about that? And, well, we're going to need public methods to do some stuff. First of all, we'll need the ability to create this box with a certain value inside. So box constructor with a value that we want to put in it. And, well then, after we have that, well, it would be nice to get that value out, so a getter. So int get val, or something along those lines. And then, well, maybe we should set the value as well, just to cover all of our bases. And that will be our box class for now. Alright, so let's go and implement this in the way that we know how. And so at the end of the day, we'll do something like, this will become beautiful after I fix it. We'll make a box, and we'll fill it, I guess, with a value 42. Maybe the default value could be like 0. If we don't give 1, and then we'll just, like, I don't know, print out the value. So this is nothing new at the moment, but we're gonna get somewhere new. Don't you worry. This is just so that we have all this ready to go. So I'll use initializer lists. The first one is this val is the private member variable, and this val is the parameter. And then we can have an empty body. Nothing else to do but set that. And for get val, we'll return val. And for set val, we'll set val equals new val. And this is looking kind of ugly, so let me reformat it. There we go. So these are our 3 functions at the moment. And let's see what it's complaining with me about. What have I done wrong? I'm sure you see it and you're yelling at me, but I cannot immediately tell, so let us see. Oh, I forgot my boxes all over the place. First of all, these are boxes functions. Dun dun dun. Oh, and when you give a default parameter, you can't give it in 2 different places. Now it's happy. Okay, so those are our functions. Let's just compile and run this to make sure it does everything we want it to do. So here I am, G++, or should we make a makefile? Oh yes, we should. We're gonna make something called box. It requires box.cpp at the moment. G++, standard equals C++17, box.cpp, which can be replaced with that. And we might as well do it. And output some program called box for us, which can be replaced with the name of the target. Alright, so now we're happy. I can say make box. And it does that. I can run it, prints 42. Alright, so that's a good starting point. So now I have a box class. It's got constructor. It's got getVal. It's got setVal. Alright, so that's our box class. And now let me show you the big three. Here they are. So there's this thing called a destructor, which is like the opposite of a constructor. And these are all member functions, so you'll define them inside of a class. They belong to a class. Destructor, opposite of a constructor. This is a copy constructor. It's a special kind of constructor, so it has the same name as the class. And what it does is it sets all of your stuff, all of your current object stuff, to all of another object of the same class. Okay? So this copies other into yourself. And I'll show examples, don't worry. And then this final one is called the copy assignment operator. And so if you use the equals operator, the assignment, between classes, so you're assigning to a class, maybe box can be, you can replace class name with box, for example. If you assign that to be another value of the same type, well, you have to go and replace or copy the other thing into yourself again. So this is like, let's write this first. Copy the other object into yourself. Okay. So you don't actually call the destructor yourself, and I'll show you an example of it running. But the copy constructor you can call. So for example, box b1, normal constructor, then box b2, make it from b1. This is the copy constructor right here. Okay? Copies another thing into yourself. So you're giving it another box and you want it to initialize, because this is a constructor, that box with this box that you're making with an existing one. And then finally, the copy assignment operator is very similar to the copy constructor in that you have another box sitting around, and you also have a box b2, but you've already constructed it, and then you want to go sometime later and say b2 equals b1, and so this will use the assignment operator. You see that? The assignment operator, and it will be trying to set another thing of the same type to yourself. Okay, so you have to go and copy those values into yourself. So this is the copy assignment operator. And you've just been blissfully unaware of these things, and they've been working in front of your eyes. So that's because there are default implementations of these things. So this will be b1. b1. And now I'll make box b2. Okay? Semicolon. So right now, I'm just calling the constructor again. Alright, so this is normal constructor call. Sometimes we say parameterized constructor call because it's this one. This is the parameterized constructor. It takes an int. This one, however, is a copy constructor call. And there is a default implementation of this. And it does do what we expect here. So if I say b1 get val and b2 get val, they'll both be 42. Okay, because if you copy b1 into b2, that means you're copying the member variables. And so it copied this val, which happened to be 42 in b1. We copy that into b2. And the rest is history. So now because it got copied. Okay, so let's compile and run this. 42, 42. All right, one more example of a copy constructor. Maybe, yeah, I think this is how I want to do it. So one more example of a copy constructor in a way that you wouldn't expect. Box B3 equals B2. This looks like an assignment operator, but it's secretly not. Because this is where B3 gets born. We are declaring and initializing. This is just another way of writing a copy constructor call. All right, so again, B2 is going to get copied into B3. Okay, so just like that. So 3 copy constructor calls. And now I can say something like, I don't know, and I should keep this as like box underscore simple or something. That was, past Lawton had better ideas. All right, so now let's talk about copy assignment. Let's give B2 the value 43, and then we'll have B3 equal B2. So this is copy assignment operator. That'll copy B2 into B3. All right, so now if I say, I just print all these out one more time, after maybe a new line, B1 didn't change, it's still 42. B2, it got whatever B3 was. Sorry, B2 is 43, and B3 got whatever B2 was, and it's also 43. Okay, hopefully this is making sense. It's just things you might not have seen before, or things that make sense intuitively. We're just going to break them down in this lecture. All right, so that is the copy assignment operator. It does what you would expect, or does it? So with that, I do want to rename this. So to box simple, and then we'll edit our makefile as well. Because this is a box in which things don't really go very wrong. This box is not really doing anything weird. Let's update our box class to do something a bit odd. So instead of holding our one thing inside of the box itself, so over here we had, if I made my box B, let's get a normal color. If I made my box B on the stack, it would look like this, and it would have its val set to 0 by default because I use the default constructor. Whereas if we make the box class hold its value on the heap, this will happen. If I say box B, what I'd like to have happen is, here's my box. It itself lives on the stack, but its value is a pointer into the heap. Whee! And that thing will get set to 0. So that's the box class that I want to create for myself. Let's do that. So because I copied box.cpp into box_symbol, I'm just going to edit box.cpp again, and all will be well. All right. So this is now going to be a pointer. So okay, and really all that needs to change are these values. So can't really use the initializer list in as easy of a way, but what we can do is we can set val equals new int on the heap, and set val to be whatever the parameter that was passed along. So now, because I need to go inside of here, I can't say val twice. I have to say starting val. And there we go. And so yeah, this val gets initialized to a new thing on the heap. Beautiful. And we set that thing to the starting value. Okay. So that's the idea. And then all of these just need stars all over the place. And now it's happy. So most of this stuff still works, right? Let's see. Remember from before, we had 42s all around, then 42, 43, all like that. Recompile. Oh, oops. Quit. Rerun. Oh! What is this? This is what we expected. 42s all around, then 42 and 2 43s. But this is what we got. Huh? So there's more that meets the eye, is the idea here, and we're going to explore that in this lecture. So hopefully you see the problem. You see what shouldn't have happened. And now we have to figure out what went wrong. And we'll figure that out together. The first thing that went wrong is something that you can't really tell. But let's start out creating all of these things on the fly for ourselves. So let's make a destructor. Okay? One got made for us automatically, and we couldn't tell. So let's make our own version of a destructor. I'm going to make it in the way that is default. All right? So one gets made for you automatically, and the default destructor just implicitly calls the destructors of all member variables that are of class type, so they're not primitive values. And it calls them in reverse order of their declaration, which is not something that you really need to worry about too often, but just remember that the constructor calls the default constructor implicitly calls the constructors of all the member variables that are of class type in order of declaration. So it's kind of like undoing what it did in reverse order, and that's useful sometimes. I can show you an example in office hours if you'd like. So that's what a destructor does. So the default destructor then, because this is all happening implicitly, has an empty body. And all right, let's make our own version then. We just need to put a tilde in front of our class name, and now we have a destructor. So moving on up, tilde box. This is a destructor. It takes no parameters ever. No. Okay, so it kind of like gets rid of things. So let's implement our own. So the default version of a destructor looks like this. It just has an empty body. Okay, this is the default destructor, has an empty body. Boxy body. And so we can't really tell that anything's happening because, well, first of all, none of our member variables are of class type. This is just a primitive thing. A pointer is a primitive value. But a destructor can have a body. Let's just say cout called destructor on box with value. Star val. How's that? Okay, if that's our destructor, now when it happens, we'll know. So when do we think in our program a destructor call will get made? And a destructor's job is to get rid of stuff. Oops. Quit. Make box / box. Aha! 3 destructor calls happened at the very end of our program. And so that's the idea. So right here, right after main is done with all its boxes, they get destructed automatically. Okay, that's what a destructor does. So it'll happen in the last line of the function call, right before the 0 gets returned to, I guess, the terminal, because this is main. They get destructed automatically. And I spelled destructed wrong. All right, so that's the idea. Get called on objects right before they go out of scope / get deleted. Okay, so let me show you that. Let me make a function called destructor example. We'll put it right here above main. We'll say void destructor example. So I'm going to make another box. And this box lives on the stack, so it'll get deleted at the end of the function. Okay? And I guess we can see that happen if I call this function. So this will get run, we'll plop up here, make a box for ourselves, immediately stop the function, it's over, and the destructor will be called because there's no reason to keep the box around. That stack frame goes away. Okay, so that happens, and then when we come back to main, we gotta clean up all the stuff we made in main, which are those 3 boxes. Okay? So that's our first destructor example. Another example is when things are made on the heap. So this box lives on the heap, and I gotta give it a different name. the destructor gets called only when it gets deleted. So if I forget to delete the box, oh sorry, I need a star, excuse me. So if I forget to delete the box, the destructor will never be called on this one. So delete v2 we'll make sure that it gets deleted first, and then implicitly B gets deleted here. Alright. So first the one with 55, because we're in this function. We said delete it first, and then the function's about to return, so delete all the local variables, if they're class types. So we deleted that box, and then we come back to main and delete the other 3. Maybe I should say, to make things easier, inside of destructor example. Yeah, how about that? And then I can say down here in main, maybe, destructor example just returned. And that should make things easier to read. Okay? So if we're inside of the example function, we'll make our box on the heap, immediately delete it, so the destructor gets called on that one first. Then the box that got made on the stack as a local variable needs to get cleaned up before this function returns. And then finally back in main, all those other 3 need to get their memory reclaimed. That's what we say. So yeah, that is a destructor, and now you know when it gets called. Alright, I had to change a few things. I will come back to this one, this fancy command, in just a little bit. Maybe I should have put it later, but now let's get into copy constructors. And what I'll do is take this program that we've been working on and copy it. So I'll copy box.cpp into this file called box.destructors.cpp. Okay? So now I have what we're working on saved right here. Okay? So now we can go back to box.cpp and do copy constructor stuff. So we can get rid of this destructor example, etc., etc. Delete that, delete that. Yeah, I think all of this printing is kind of unnecessary. We noticed a problem, and we'll keep it. We'll keep the problem, but yeah, let's talk about copy constructors in depth. So the default copy constructor, what it does is it calls the copy constructor on each member variable in the order that they're declared. So let's implement our own handy dandy copy constructor. So what it'll look like is it's the same name of the class. You can have as many constructors as you want, actually. You can make one that takes a double, maybe multiple things. But this copy constructor, it's special because it takes something of the same type as our class. And usually you take it by constant reference, but you don't have to. You can just take it by value, by reference. So that's our copy constructor. And if we go and implement it, box, box. Oh, and before I forget about it, I am so sorry. Get val. That should be const. What was I thinking? Okay, so back to the copy constructor. So what it does by default, by default it does just this. We only have one private member variable, this one right here, val. And so all we have to do is initialize that using that constructor style syntax, even though it's a primitive value. And that'll just set our value to the other's value. Okay, and we can have an empty body. So that's a default copy constructor, and we would like to see when it happens, so we'll print it out. Called copy constructor. With the other's value equal to. Okay, that's the idea. And now we'll see it happen. So copy constructor got called there, also here. I don't know why that is like that. This is a copy assignment, so we won't see it there, but we'll see it twice otherwise. So make box. And so, yeah, the first time we call it on B2 with B1 equal to the thing that we're copying, so that's equal to 42, and again 42, because when we copy B2 into B3, B2 also has its value set to 42 because it itself got copied, which is fun. Okay, so those are copy constructors, and one thing is that copy constructors get called at interesting times, and one place that you might not expect it is in parameters to functions. So when classes get passed as an argument to a function, let me do this so it breaks the line correctly. When they get passed by value, that is, not by reference, not by pointer. And I'd like those to be on the same line so that we can read them. When they get passed by value as an argument to a function, the copy constructor is implicitly called. Alright, so this is a lot of words. Let's see what that means. So let me make just a simple function that like increments the value inside of a box. So I don't know, void inc, or no, it needs to return a box as well. Box inc box, I don't know, something like that, and it'll take another box by value this time. So it'll make a new box with B's value +1, I guess. So return new incremented box. That's what this function does. And yeah, so this will take it by value. And I am not yet sure why it is complaining. Oh, I forgot to return the value. I made it inside the function, but I never returned it. Sorry. So taking a box by value copies the argument into the function. Okay. So what will happen now when we call this function? Let's do it down here. We'll say I don't know, box B4 equals inc box B3. Dun dun dun. Nope, I forgot to put a new line in here. That would have been helpful. And maybe we can say finished calling inc box as well after. 2 new lines. Two new lines at the beginning too, just to separate it all. So when we call inc box, we call it with B3, and apparently B3's value is equal to 43 at the moment. And what happens is it's can I put all these in the same? Not quite. Oh yes, yes I can. So when we call it with b3, we copy b3 into this parameter b when this function gets run. So now we're going to have a copy constructor call before any of this body gets executed, and so it's happening right there. And because we constructed it, we also have to destruct it because it's a local variable. It's a brand new local variable just to this inkbox function. Okay? So right before we return, we also destruct that box that we copied in so that we could use it to make this new box that we return. And it might surprise you that when we return a box, we also don't copy it down here. This looks like a copy constructor call as well. But C++ is a bit smart. So it's going to is able to catch this. This is like, I think it's called copy constructor elision or something like that. So it's not actually copying the return value into B4, it's just like putting it there. It's saving itself some time. But when you call the function, when you pass along an argument to be set as this parameter's value, it's getting copied. Okay, so that's one place that you might not expect a copy constructor to happen, but now you know. All right, so with that, let's see how we're doing. I want to get into copy assignment operators, and I think we can probably save the rest. So copy assignment operators, we know what it looks like. Gosh, maybe I should do the same thing. Let's copy box.cpp into box copy constructors. So now we can get rid of all that extra stuff. We don't need to talk about inkbox at the moment. We know what it does now. We don't even need the function anymore. Okay, but it is saved forever. So now, we know copy assignment, it's happening. We know where it happens. Let's break down exactly how it happens. So, in detail, copy assignment, the default copy assignment operator that's made for you just uses the copy assignment operator for every member variable in order. To the other values, contents, default copy assignment operator sets each member variable using their own copy assignment operator to the other values, to the contents of the other values, let's say. The others values, plural, in the order that they're declared. And that's hard to explain in English, so let me just show you what's happening. So, copy assignment, this is what it looks like. You return a reference to yourself. We'll talk about that. So that's its return type. It is called operator equals for assignment, and it takes another thing of the same type, so const box reference other, and it doesn't have to be a const reference, but usually that's the best thing to do. And so that's your copy assignment operator. Okay. And let's go and implement this down here. So it's boxes copy assignment operator, And what it will do by default is just use the copy assignment operators of all the member variables in order. So since we only have one, remember, we have our val up there. We just have one, so what we'll do is just set that. So val equals other dot val. That's a copy assignment for that type, whatever it was. And we have to now return ourselves. So this is how we do it. Return star this. And this is a pointer to the current object. So we're kind of returning a reference to ourselves. So we dereference our this pointer, and we get a box, and by saying we wanted a reference, it'll just make it one when we return it. So we're returning a reference to ourselves, which is weird. Why do we do that, you might ask? Well, the reason, if I give myself some room, is so that you can do this. You can say box b1, b2, b3, and maybe we say, like, I don't know, b1 dot set val to some cool value, like 42. And the reason you can return a reference to yourself, and you're supposed to, is so that you can do this. You can say, b2, I like that. I like that 42. I want that. That's one copy assignment. But then you can also do this on one line. And this is the reason you return a reference to yourself. So this is what you gain from that, because what happens is the parentheses, C++ draws, look like this, and so it will run this assignment first, and if the result is b2, then it will transform this into b3 equals b2 after running b2 equals b1. So it'll do all of them at the same time. Okay? Or there is an order, but that's the idea. So that's what you gain by returning a reference to yourself. And so that's a copy assignment operator. And let's see what's going on here. Well, we should maybe print something out. Let's do the same thing that we did for the copy constructor. All right. So we should see one call to that right down there. And that's where it happened, called copy assignment operator with other.val equal to 43, because we just set that its value to 43. So b2 equals b3. We're hitting the copy assignment operator. Okay, and then our destructors are still getting called because everything's going out of scope. And yeah, that is essentially all that you need to worry about, but also I haven't shown you the exact implementation, the exact default implementation for a copy assignment operator, because it guards against the following. b1 equals b1. Right now, that's not really going to do much for us, but this could be an issue later, and I'll show you that in a second. So really, this can make things weird. And we don't want to waste time if we're setting ourselves to ourselves. So what we can do is up here, if this, which is the pointer to our current object, is equal to the address of other, if that's ever true, just return. So it's possible that this class is now having, like this box class is having an existential crisis, and so it's trying to set itself to itself, but it's already itself. It can't get any more itself. So we'll just return this. Okay, that's the idea. So that this down here is the complete default implementation of the copy assignment operator. All right, saves work. Now, right now, I think we have a few issues. So let's see how we're doing on time. We might have to save a little bit for later, but one issue right now, if you remember, what should happen when we call this program? We want to set B1 to be 42. If B1's 42, that means its value is set to be something that is 42 on the heap. That's B1. And then we say B2 is the same as B1. So we'd like something like this, B2 val. Same as B1, so 42. And then we'd like B3 equals B2, that's another copy assignment, so B3, its val is equal to whatever B2's val is, 42. Then we'll set B2's value to 43. And set B3 to be B2's value, so 42, 43, 43. Just like that. And then we'll print them all out. And if you remember, we're getting 43, 43, 43. What in the world? That is an issue. And, well, what's going on there? If we look at the default implementations of all this stuff, and we execute them, then we can see the difference. So when we call box B1 42, yes, sure, this is what we like, what we want. And this is what we're doing. Right now, yeah, B1, val, pointing to the heap with a value set to 42. Because val, I don't know, it's address 100, and this is at address 100 on the heap, let's say. Then we say B2 copy constructor B1. B2's val, with the copy constructor, the default copy constructor, let's see here. Here it is. We set our val to others.val. So this box gets set to whatever this box is, and do you see the problem? 100. Oh, that's pointing right there. Ooh. Ooh. Okay, this gets more insidious. Now, how about B3 equals B2? That's another copy constructor call. We know what's about to happen. Just set the vals. Just like that. B3 val 100 because we're setting the vals contents. Those are just addresses. Oh my goodness. And when I say set val, that's going right here and changing it to 43, so everybody gets 43 at this point. Everybody. So this kind of did nothing. All it's doing is setting B3's val. Where'd that go? Yeah. B3's val to B2's val, but they're the same address already. If we're just working with pointers, it's like, yeah, 100 again. You didn't change. So you're all pointing to the same place and nothing really happened. So this was not what we wanted, and this is the default. Okay, so, I don't know. Sad face. We don't like that. We were just using one place on the heap this whole darn time. What? What is going on here? And then, to top it all off, we have a memory leak. We have several memory leaks. The destructor does essentially nothing to a pointer because it's a primitive value. So it's not deleting it. That's a memory leak. No. The whole world is exploding right now, and we're just sitting and watching at the moment. So we have a memory leak, and we can discover that with a tool called valgrind. We can say valgrind leak dash check equals full dot slash box, and it's going to be like, bro, definitely leaked some stuff. And if you call this, I can show you how to do this maybe in a future class, how to do this fancier, but it's going to tell you, yeah, you had some memory leaks, dude. Your destructor is useless at the moment. So, we'd also like when everything goes away for the following to happen. Boop, boop, boop. But what we're doing right now is we're keeping everything, and also it's all wrong. So, gosh, I think that's almost where I want to leave you. We'll talk about this thing called deep copy versus shallow copy, and then we'll have to fix our boxes next time, okay? Deep copy versus shallow copy looks like this. What we had was the default. We set pointers, and so we gained, we're just working with the same object on the heap this whole darn time. We don't like that. What we want is this, picture 2, where we're making a copy of that thing whenever we set it. Okay, so we made a copy. And this is like, use the same one. Okay, so technically both of these pictures are copying x into y, but we prefer this one almost every time. Because now if you use y, you're touching x's values, and vice versa. This way, there's like a separation. And so this is called a shallow copy. You're copying pointers. And this is called a deep copy, where you're copying values as deep as they go, following all the pointers. Okay. So, deep copy versus shallow copy. The default copy constructor and copy assignment operator, they perform a shallow copy. So if you got pointers, they're just setting pointers to other pointers, not the values that are being pointed to, so we saw that. So a deep copy is when you copy all the data as far down as you can go, and depending on our time, I might come back and fix it in this lecture, otherwise we'll wait until the next one to fix our box. And yeah, we got some time, so let's do this. Let's fix this mess to work like this. Okay? So the first issue that we saw, let me copy this file into box complete but horrible.cpp, a nice name, and then let's edit box again. And this time, let's do what we should have done. Constructor is fine. It knows what it's doing. This bad boy has a memory leak, and we're going to fix that. How? Well, we're just going to delete our value. Yeah. Now, it got deleted off the heap. There's no more leak. But given the other issues, because everybody's pointing to the same thing at the moment, this will actually cause a seg fault, because we're going to try, B1's going to delete itself and delete this thing off the heap, and then B2 will try to delete the same address, and that's called a double free, and we don't like that, so we don't do that. And so this is part of the solution, it's just there's still a huge problem. So we don't like this default copy constructor either. What we want to do is make a brand new place on the heap for B2 and copy the value from B1 into it. Alright, so what we're going to do is not this. None of that. We're going to make val equal to a new place on the heap, just like we were doing in the normal constructor, and then we'll set that value to others val in its own little version of the heap. You see that? This way, we're making a deep copy. Alright, we're copying those values that are deep down. So now, val is a new place on the heap. It's a new box that we can put something inside, and we'll put whatever was in our other box that we're passing along to copy. And that's glorious. This is exactly what we want. And so here, we'll do the same thing. Val equals new int, star val equals star other dot val, return star this, and right now, we also have a problem there. If I do the following, if I say box B1, I don't know, with 42, box B2, I guess this is just B, and then I say B2 equals B, well, here's what's going on. Stack heap. At the moment, in our current implementation of the copy assignment, which was very similar to the copy constructor, this is what's happening. B val, it holds something with 42 in it, and then B2, when we call it with its default constructor, it's going to look like this. Val 0. And then when we say B2 equals B, what's going to happen to B2 is we're going to make a brand new place on the heap, right? And set it to be 42, and then change B2 to not point there, but to point to its new place on the heap, 42. Ooh, that's a problem. And so there are two solutions. You'll see that this is a memory leak, I hope. There's no way to access this heap memory ever again. And the way to solve this, there's two ways. At least in this case, it's, well, you can just reset this box that already existed in memory, or you can delete the old thing before you make the new one. And to make your lives easier when you're implementing this for vectors, I'm going to do that last idea. So first delete ourselves. We're going to replace it. So we'll say stuff like that. Oops. So we'll say delete val, and then we'll replace it. Okay, and so this will fix the problem. We had a memory leak, but now we don't anymore. Alright. And I encourage you to just try and make this clear. Please come to office hours and yell at me about this stuff. This is a hard topic. I'm just trying to show you as many examples as I can of it. Okay, back to our idea. So now we've got all this stuff working for copy constructors, copy assignments, and destructors are actually deleting things. Is that enough? So what we'd like is, we'd like to see the following. Let's say b2 dot b3 dot set val to whatever it was +1, and have that not change everybody else. So we want to see this now. So b1 holds 42, it never changed. b2 holds 42, b3 holds 42, Now it's B2 holds 43. It's probably better to just draw this. So this is what we've got. Let's see if it worked. We had B1, val, which held 42, and our new copy constructor is going to make a new place in memory for B2, and it'll hold whatever B1 held, so we're copying the values, a deep copy. B3 equals B2, another copy constructor call. Val. So they're all holding 42 in 3 separate places, and you can print out val to get the address and determine that that's correct. Then we'll set B2's value to 43. Then we'll set B3 to B2, which will hopefully do the following. 43. Get rid of that one. And then we'll increment B3's current value to 44. So when I print everything out, I should see 42, 43, 44, if we did it right. And we'll have no memory leaks as well. Beautiful. Beautiful. Let's check our friend Valgrind. All heat blocks are freed, no leaks are possible. That's what I like to see. So we just fixed everything. So you just noticed that if I break it down, recap of what we just talked about, the default implementations of the copy constructor, copy assignment operator, and destructor sometimes suck. We went and fixed them to do what we thought should be right, okay? You'll have to go and fix them if you don't like the defaults. And warning, or just for your information, it will be quite often in this class that we won't like the defaults. And yeah, that is what I want to leave you with there. In conclusion, I guess, that brings us to this idea of the rule of 3, and I think this is where I want to bring us back next time, so I'll just stop here. But the idea of the rule of 3 is you change one, you gotta change all of them, all 3. Okay, so I'll see you here next time.